simplify fully without using a calculator. Okay, you guys know that the bth root of x to the exponent a is the same as x to the exponent a. And then if you want to get the root of the root sign, you divide this exponent by whatever is here. So it will be x to the exponent a over b, right? So for an example, if we have 3 to the exponent 4, the cube root of 3 to the exponent 4, this will be 3 to the exponent 4 divided by 3. By dividing this exponent by this number, we are getting rid of the root sign, right? You guys know that the cube root of 27 is 3. So this is the cube root of the 27 is the same as 3 cubed. And then this will be 3 to the exponent 3 divided by this number to get rid of the square root of the root sign, sorry. Therefore, this will be 3, right? So let's get into the question. Oh, I did not say that in vain. I was not saying it in vain. So 29 will be 9 by 3 and to the 6. You remember we want to break it down into two numbers, one being a perfect square. 48 will be 16 by 3 and to the 6, right? 12 will be 4 by 3 and to the 6. So far, so good. The square root of 9 is 3. And then this, if we want to get rid of the root sign for n, we divide 6 by 2. Therefore, it will be n to the exponent 3. Therefore, we will only left with the square root of 3 under the root sign, right? The very same here, the square root of 16 is 4. This, the square root of n to the exponent 6 will be n to the exponent 3. We are only left with the square root of 3. And then this, the very same, this will be 2n cubed, the square root of 3, right? So in this case, at this point, we can say, okay, let's take out the square root. Let's take out n cubed as a common factor. N cubed as a common factor will be left with the square root of 3. 3, the square root of 3 minus 4, the square root of 3 divided by n cubed into 2, the square root of 3. This one will cancel out with this one. Therefore, the square root 3, the square root of 3 minus 4, the square root of 3. These ones are the same. So this is the same as 3 minus 4. This is minus 1. So this will be minus the square root of 3 divided by 2, the square root of 3. These ones will cancel. Therefore, this is the same as minus a half. Exponent, the first law, multiplying powers of the same basis, we add the exponent. So if we have x to the exponent a multiplied by x to the exponent b, this is the same as x to the exponent a plus b, right? Dividing powers of the same basis, we subtract the exponent, right? This is a power, this is an exponent, this is a base, right? The whole thing is a power, right? Okay, dividing powers of the same basis, we subtract the exponent. So in this case, we'll have a minus b, right? Right? But with this one, I want you to be careful with this one. X to the exponent a minus b can be written as x to the exponent a over x to the exponent b, or it can also be written in terms of the first laws of exponent as x to the exponent a multiplied by x to the exponent minus b, because now in this case, if we are to add the exponent, we'll have a plus minus b, and then we know that positive by negative is negative. So you can see that it gives us the same thing. It gives us the same thing. So this one can be written in two different ways, right? So we will manipulate it accordingly. It will depend. So in this case, we want to break everything down. We want to break everything out. So we have 5 to the exponent m multiplied by 5 to the exponent minus 2, right? So basically, we are reversing the law, right? We are going backwards. Multiply by 2 to the exponent m by 2 to the exponent 2. We are happy. Down here, let's do the same thing. 10 to the exponent m minus 10 to the exponent m by 10 to the exponent minus 2 by 2, right? Okay, let's simplify. Up there is no common factor. Let us group the like terms. We have 5 to the exponent m multiplied by 2 to the exponent m, right? Okay, and then here, I hope you guys know that x to the exponent a, if we want to write it in terms of a positive exponent, this is the same as 1 over x to the exponent a, right? Right, so this is the same as 1 over 2 to the exponent 5, which is 1 over 25 by this is 4, right? 2 squared is 4. So down here we can take out a common factor. Our common factor is 10 to the exponent m. Therefore here we'll be left with 1, minus here will be left with 1. 1 times this is the same as 1 over 10 squared, which is 1 over 100 multiplied by, okay, let's put this one here, right? Multiplied by 2. If it makes no difference, but let's put it. So this 5x divided by 2x is the same as, according to laws of exponents, is the same as 5 divided by 2 all to the exponent x, right? Similarly, 5x multiplied by 2x, according to laws of exponents, is the same as 5 by 2 all to the exponent x, right? Meaning 5m 5 to the exponent m by 2 to the exponent m is the same as 10 to the exponent m, because it will be 5 by 2 to the exponent m. 5 by 2 is 10, right? 10 to the exponent m into this by this 1 by 4, 4 over 25. Okay, we're good. Divided by, we have 10 to the exponent m into 1 minus 1 by any number is that number. 2 by 1 over 100. We have 2 over 100. 2 over 100, which can be simplified to 1 over 50, right? Okay, we're good. So this one can cancel out with this one. So we have 4 over, you remember we are simplifying without the use of a calculator. 4 over 25 divided by, so this is the same as, okay, 1 minus 1 over 50. This by this is 50. 50 minus 1 is 49 over 50, right? So this is the same as 49 over 50. They said we must simplify without the use of a calculator. Okay, multiplicative inverse, numerator changes into denominator, right? If we change division into multiplication, the numerator 50 was the denominator, it becomes the numerator, and then the numerator becomes the denominator, right? Okay. Okay, 25 goes once here, and then it goes twice here. So this is the same as 2 by 4 is 8. This is the same as 8 over 49. Last question. So basically here, guys, they're saying simplify this so that it can be in this form, and then just compare the numbers, right? So we know the drill up until this point. We know that we want to break down these numbers into two numbers, one of which being a perfect square, right? So in this case, 63 will be 9 by 7, right? And then 28 will be 7 by 28 will be 7 by 4. Yes, 7 by 4, right? Okay, so we have 14. The square root of 9 is 3. So 3 the square root of 7. And then in this case, the square root of 4 is 2. 2 the square root of 7, right? Okay, then we have 14. 3 the square root of 7 minus 2 the square root of 7 will be left with the square root of 7. When we get to this point, we can rationalize the denominator. We multiply by the denominator. We multiply both the denominator and the numerator. So this is the same as multiplying by 1, right? So we are changing nothing. So we'll be having 14 the square root of 7. The square root of 7 by the square root of 7. The square root of 49. The square root of 49 is 7, right? So in this case, 7 goes once here, and then it goes twice here. It goes twice here. So we have 2 the square root of of 7, right? So 2 the square root of 7 is equals to 8 the square root of b. You can clearly see here that your a is equals to 2, and then your b is equals to 7. Your b is not equals to the square root of 7. B is whatever is under the square root, right? So b is equals to 7.